Here's some questions that look at exponential growth functions and solving for them. The first one involves population growth, and they talk in this question about something that's doubling time. So they give you the doubling time, and what doubling time means is the time it would take a population to go, say, from 1,000 people to 2,000. So that would be doubling time. So they give you the t value, and they're looking for the growth rate, which is k. So they say in 77 years a population will double. So they're looking at what that growth rate constant is. So if we look at our formula, P of t equals P0 e to the kt, I know that, so I have e, k is what I'm looking for, and t is 77. So times 77. Now it's this P0 and the P of t that is usually trouble for students. If they say doubling time, it means you can start with anything you want as long as you double it. So say I start with 1,000, then in 77 years that population will double from 1,000 to 2,000. And so I can solve now this equation to figure out what my k value is. Okay, first thing I'm going to do is divide both sides by 1,000. So I'll get 2,000 divided 1,000 is 2, is equal to e to the k times 77. And then I'll change this from exponential form to log form. So it'll be log base e of 2 is equal to k times 77. Now in the book, I think that they actually just, rather than do this first part, they just go right to this, to ln 2 is equal to k times 77, or they might divide by 77 already as well. So ln 2 divided by 77. So they might do that, like they might start the formula right there. And that's not bad, but you're sort of skipping a bunch of steps. Just, that's my take on it. All right, so on my calculator, I'm going to go ln of 2, bracket, divided by 77. Good, so my k value is, that's a little one, 0.009001, etc. I don't know if they didn't tell me what to round it to. This one rounded to 3 numbers. I'll maybe do that. So if I wanted to change, this would be okay here. You could write it as 0.00900. In chemistry, we do sig figs, but you can also change this to a percentage. So if you change it to a percentage, you have to times it by 100, so it would come out to 0.900. So that would be the k value. And so if you wanted to know, okay, what would the population be, say, after 90 years, you could use this k value and search for t and figure out, what am I asking? Oh, how many people there would be after 90 years. Okay, now another question that we had, and this is a similar kind of question. It's a carbon dating question. They said scientists determined bones had lost 77.2% of their carbon. So that means they must have started with 100% and they went down. Oh, they lost 77.2, so they would be down to 100 minus 77.2, I think is 22.8. So they might have started with, say, 100 grams, and now they're down to 22.8 grams. So this would be the starting number, and this would be the finishing number. And the question is, how old were the bones? So they're looking for T. Now, one thing they didn't show in this question that you really need to know is what the K value is, or that interest, if you want to think about it that way, the growth or decay rate for carbon-14. If you look back a page or two in the textbook, they actually did a question where they said that the half-life of carbon-14 is 5750 years or something like that, and they did a bunch of calculations to come up with that. On a question on a test, I'll either give you this number, that's the half-life, and from that you can get K, or I'll tell you what the K value is. In either case, to solve this one, you needed to know what that K is. So again, same formula. P of t equals P0 e to the kt. Notice I'm not putting a plus or minus up there, just because it depends on the question. Like, k is going to be negative if I'm decreasing, if I'm going down. k will be positive if the population or whatever is increasing. So I just take it by which question I'm working on to figure out which, if I needed to put a plus or I need to put a minus there. Okay, so they say they started with 100%, and if they lost 77.2, they wound up with 22.8%. And notice that it doesn't, those are percentages, but I could call them grams if I wanted to have a bigger number, like if I wanted to say, I don't know, 4,092 is my first number, I'd have to make sure I'd get 22.8% of that number to put here. But it's easier just to put the percentages. E to the, since this is a decay, I'm putting a negative 0.00012 times t. Okay, similar to the last question, I'm going to have to isolate this, so I'll divide both sides by 100. So that'll give me 0.228 is equal to e to the negative 0.00012t. Change it from exponential to log form. So it'll be log base e of 0.228 is equal to negative 0.00012t. Dividing both sides by that, I'm going to come up with t is equal to the ln of 0.228 divided by negative 0.00012. Calculator time. So ln of 0.228 bracket divided by negative 0.00012. Go. Ooh, that's old. T is equal to 12,320. I think I did that right. Yeah, it looks right. Hopefully that's the right question, or the right answer. I'm just wondering about that positive versus negative. No, I think it'd be right. It would have to be right because the answer came out to be positive. Okay, so this jawbone thing, we're calling that guy 12,000 years old. Okay, another similar sort of related question would be something like this where you have radioactive decay. They're telling you polonium, lead, or iodine. And the first two questions, they want to know the decay rate, and they give you what the half-life is. Again, the half-life means if I start, say, with 10, then after 3.1 minutes, that'll decay to 5. So that's after 3.1 minutes. If I wait another 3.1 minutes, it's going to go half of 5, which is 2.5. If I wait, you get the idea. Okay, so I can use my same formula. P of t equals P0 e to the kt. So for half-life, I'm going to just, let's say I start with, I don't know, 10. So e to the k, I don't know. I'm solving for that. But it takes 3.1 minutes. Okay? And so it goes from 10 to half of that, which is 5, in 3.1 minutes. Okay, divide, so 5 over 10, that'll be 1 half, or 0.5, is equal to e to the k times 3.1. Change from exponential to log form, so ln of 0.5 divided by 3.1, that'll be what my k value is. So let me do that. Ln of 0.5 divide 3.1. So my k value is negative 0.22359, etc. Which again, the k values I can write as a percentage, so it'd be negative 22.4%. That'd be what your k value is. Notice it's negative, and it's negative because it's going down. It's getting smaller. All right, hopefully that helps you with those questions of exponential decay or growth.